Hello, this is Schweitzer, and this is a series of videos, and we're looking to see, are you proficient? The standard we're dealing with here is standard 4-1A in states of matter. So our main objectives here is, why is a solid a solid? What are the internal and external factors? Well, 1-A says what are 4-1A, or what are the external factors causing something to be a solid. Alright, our first question, again, the main objective here would be to just having some questions to try and run yourself through. Pause the video, answer the question, check your answer. Our first question is, we have a heating curve here. Student hypothesis, the liquid will always have to be hotter than the solid. Again, pause your video, answer the question. Here's our answer. Student hypothesis, the liquid will always have to be hotter than the solid. Well, a couple of things we would note about this is that right here, and right, grab a pen here quick. Okay, this particular substance, this right here is a solid. This substance right here is a liquid, and this here is a gas. So right here, and I guess I'm assuming we're looking at about 50 here, is your melting point. And this substance right here, probably around 100, is your boiling point. That's the temperature which you're boiling. Alright, so it turns out that if this were some substance, you would have to have a solid right here. That could be 50 degrees. And you could have a solid, a liquid right here at the same temperature. So as you're going through a phase change, this is going to be called delta H of fusion. And of course from here to here is delta H of vaporization. And this is literally just an energy per mole. It'd be in typically kilojoules per mole ratio. As far as how much it takes just a little energy to flip phase and not increase energy. So the answer is false. You can have a liquid that is the same temperature as its solid. Next question. The area of greatest increase of translational motion is in what region? Go ahead. Okay, here's my answer. Right here we have a solid, we have a liquid, and we have a gas. Of course, these are again external factors affecting a solid. So this isn't necessarily a solid, but it is going to be in this region right here, region F. There are two types of motions. There is a particle that can spin around in a circle, and we might call this rotational motion. But, and this is quite prominent in, let's say, in a solid. Almost all rotational motion. But if we have a liquid, now a liquid is going to start in a container, to start to be able to move around translationally. So from this situation right here, this amount of energy, from when you melt it, you're essentially going from a solid which has only rotational motion to a situation where we now have some translational motion. Moving side to side. So again, this translational motion has kinetic energy, and therefore that is a big reason why delta H here is requiring energy to create that kinetic energy. But here is we're going from essentially substance that has, a minor amount of movement here to essentially a particle that is now airborne and has a massive amounts of translational energy. Um, its ratio of translational to proportional is really top heavy in terms of translational energy. Next question. Question. Okay, it says if energy is added to this substance, the temperature will increase. All right, so on this one here, of course, this is a classic question that really stumped people for a long time, and we kind of alluded to that already. But at the phase changes, we're still going to be adding in energy in these areas, yet we have no increase in temperature. This threw off people for thousands of years, and they really thought that we had heat and temperature were essentially the same thing, and they just aren't. So um, that's it. The answer is false. At transitions, it's not true. Everywhere else, yes. Everywhere else through here, if you add energy, you will increase temperature. And in this, it would be Q equals mass times change in temperature times the specific heat of an item. This is the energy in joules that you're adding. This is the change in temperature. This is the specific heat, and this is the mass. So that's for the thermodynamics chapter, but that's it. And that ends our 4-1A.